Our technical keynote today will be delivered by Grahame Grieve. And for those who are digital health, interoperability, and integration enthusiasts, I'm sure someone like Grahame Grieve is not unfamiliar to us. Grahame Grieve is HL7's product director for FHIR, which is the leading healthcare data exchange standard of the future. Grahame has a background in laboratory medicine, software vendor development, clinical research, open source development, and has also conceived, developed, and sold interoperability and clinical document solutions and products in the Australian market and around the world. Grahame has worked to develop standards and solutions with several US vendor consortiums and the national programs of Canada, England, Singapore, and Australia. And in the last decade, Grahame has focused on nurturing and leading the FHIR community around the world. We're very excited to hear from Grahame today and for him to impart some knowledge around FHIR to us. So thanks, Grahame. Welcome for being here. And please, over to you.
Thanks very much. So it's a real pleasure to be here with you. I'd love to be there in person, but can't be everywhere all at once. And I would be in Kigali if I was allowed to travel right now anyway, but there you go. Happy to be with you this way. Tell you about FHIR and a little bit about identifiers. And you know, I started FHIR because I recognized that everywhere I went in the world, whichever part of the world it is, healthcare has broken processes. And you know, it doesn't matter how much money you throw at the problem, and some countries do, but the processes are broken. And I was watching other industries being transformed and seeing that IT enabled that transformation. It wasn't that transformation, but it was enabling it. But that was not happening in healthcare. And I believe that one of the reasons was because the proper IT standards that would integrate business to business and consumer to business, they did not exist. And what did exist was not well implemented. And business was really moving very slowly. And from where I stood, from my family, I wanted faster care, faster transformation in the way care is practiced. I want to be clear at this point. IT standards are enablers. They're not the change that we need. But in the absence of them, we can't have the change that we need. So my goal, the bit that I took on, was to write the standards that I thought that we needed, and hope that other people stepped up to make the change that we need. But doing the standards is enough for me, and I've been very lucky and honoured that the whole world has jumped on board and said this is the way we're going to do healthcare data exchange in the future. So here we are. That's why FHIR. And for me, it's really the web for healthcare. And it's two parts. There's two parts to it. One is the community, a way of getting together as a group with the goal of making it easier to exchange healthcare information based on open participation. So web infrastructure, social media, you can, it's free to participate. I don't even know how many people are in the FHIR community because you don't have to tell us. You just have to join us. And every one of you joins for the same cost base as anybody else, which is nothing, just your time. We are led by HL7, which means we're deeply connected to the worldwide health community. And what we do is we write a standard, a technical standard that describes how to exchange healthcare information. It's public domain. I'll come back to that in a sec. It's a web API. We use the web where possible. And it has continuity with existing healthcare standards. It's probably more important in the places where they've already wasted a great deal of money on bad interoperability. But still, people really care about their health, the health records they have, and we want to bring them forward. And that's, for me, this is what FHIR is at the highest level. And it's an API, a list of operations that programs can use. And those operations are offered using web technologies, which means they seamlessly work across the internet or locally with common technology that everybody knows how to manage. But what FHIR does is defines healthcare relevant operations that other programs can use to achieve healthcare outcomes. Sometimes they're just about moving records around, but other times they're actually about, real change, prescribing, administering, driving medications, driving pumps that actually inject medications, And by so doing, they seamlessly enable the healthcare workers to provide healthcare services. And you can see some of the healthcare services we define there. One of the things that was key from the beginning for me, which was brand new for healthcare standards, was it's freely available. So for the entire world, it's at http:/hl7.org/fire. That's where it is. Everybody in the world knows that's where it is. Everyone who cares knows. And the license is Creative Commons public domain, which means that HL7 has no rights reserved. You can do whatever you want with the content. And for me, the whole point of this was the big expensive vendors, they had it all sewn up. You had to be a member, you had to play ball with expensive memberships in order to use or deal with the standard. Fire's not like that. You, anywhere in the world, and I know that Africa is cost sensitive here, can do whatever you want, and you can collaborate, which is really hard with some standards, healthcare standards, to collaborate to write open source software. The Android SDK for Fire, which I'll hopefully will remember to come back to, couldn't exist without the Fire license. And I wrote the license specifically to enable things like the Android Fire SDK. So anyone can do anything with the content. HL7 doesn't have any rights. We do protect a trademark, but not the content of the standard. And that protects HL7's investment without holding anybody back from doing whatever they want. And I did that for equity. We talked already in this talks this morning about equity, and I did that for equity. HL7 is an international standards organization. You do have to pay money to be a member of HL7. That part is true. I can't do anything about that. And it's an international standard organization that works with governments and vendors and providers and payers and public health authorities and the WHO to define and publish healthcare data exchange standards. And we've been doing it for 40 years now. And Fire is the latest and greatest, which is gradually taking over. And so HL7 has a partnership with Helena in Africa. But I would love all of you listening to me, please be involved and drive HL7 to care about Africa, because we care about who our members care for. And so please join Helena or join HL7 and drive us to pay more attention to Africa. So I started with this idea, and a small passionate community rapidly grew around the idea, and we built specifications and tools and demonstrations and web presence, and we took some exemplars into production, and then we were selected by the big US EHR vendors, and then Apple, and then Android, and there's various national uses around the world, including, I was in Zanzibar a few weeks ago with the Tanzanian and Kenyan national programs, working on national specifications using Fire. I counted recently 90 countries I've heard of doing projects with Fire. And so it's just snowballing, and I can't keep up anymore. I was at a conference and someone from Macau came up to me and said, I just want you to know the entire health backbone in Macau is based on Fire. I haven't heard anything about that before or since, but he was the CIO, so that's what he told me. That's how it works. And for me, that's good. You don't need us. We can help you, and we'd like to help you, and we want to know what's going on, but you don't need us, and that's how it should be. And here's a map from around the world of hits on one of the open source test servers. And you can see that we get hit from all over the world. The massive blue dot over Chicago is an Amazon data center running a bunch of Fire integrations. And there's another big one in Mumbai. But other than that, pretty spread across the world, but I'd love to see more dots in Africa. In fact, this is a few years old now. I really need to get an updated one, and there would be more dots in Africa. And there is, at least there's one in Nigeria. That's something, but let's have more. But you can see we're all over the world. But and this is where the going gets hard. I love Fire. It's my baby. I've dedicated 14 years of my life now to Fire, but it's not a silver bullet. It's nice, but it only captures what everybody agrees to. It's an international specification that makes rules that everybody in the world agrees to. And honestly, it's not enough. It's a platform on which you can build more agreements, but you still have to actually form those agreements. And the smaller your community, the more you can agree about, because the more you have in common: countries, domains, terminologies, business agreements, vendors, providers, universities. Yeah, and you have to agree about why you're doing what you're doing and regulation. And so as you get to a smaller and smaller circle, you can agree about more, and then you have to actually make those agreements. In some fantasy, we get all of the governments and all the vendors and all the providers and all the doctors who make decisions, and we get them all in the Maracana in Rio de Janeiro, and we surround it with guns and say, you can come out when you've agreed on everything. It's never going to happen, right? It's not something that can happen. And so we still have to work hard at what we do. And today, the committee, they asked me to talk about identifiers. So dive in and talk about some of the common challenges around identification from my perspective. And I'll tell you that this is a problem everywhere, every project, everywhere, every vendor, every platform. So let's dive into identifiers. But just to frame things, in order to communicate between people or between computer systems, we need some things in order to do that successfully. We need to be able to hear each other, some kind of communication medium. It's going to be the web. We need a set of words that we all understand, which are common terminologies: LOINC, UCIM, ATC, drug lists, ICD-10, I should have put ICD-11's coming. We need those as common words that we share that provide meaning. We also need shared identification, which means that we can name things and know that we've successfully named the same things. I want to focus a little bit on the theory of identification and then how that looks in FHIR. And we need common information structures, sentences and grammar and meanings so that we know what we're saying to each other. As our FHIR brings to the party, we have experience with doing this in other ways, and we've learned from that. And hopefully with FHIR, we're starting to get it right. And then exchange protocols. Who's going to say what when? Humans don't do well with this. We go to war over this stuff, but computers, they got no flex. So we have to get the protocols sorted. FHIR does that too. We also need shared authorization, which, we can do through OAuth on the web or other ways. Who is allowed to say what? And finally, the more common understanding we have, mediated by organizations like HL7 or DHIN, the more we can take for granted and the more efficient our communication will be. And so these events, these organizations, they're critical for driving interoperability. But now I'm going to pick the identification piece. If we're going to interoperate successfully, we need to be able to consistently and reliably identify people, whether they're patients or staff or family or organizations or doctors. We need to be able to do that reliably and talk to each other, exchange those identifications. So identifying people is critical to getting interoperability right. The right patient, the right family, care providers, organizations, etc. And identifiers are assigned to people and to organizations. They're not a natural feature. People are not born with a barcode on them. I did know one person with a barcode identifier on him. He was an inmate at Bergen-Belsen. He's passed away now. But for the rest of the world, the normal people, identifiers are assigned to people by some process. Some countries assign identifiers at birth, and some have national identifiers. You have the DHIN. I looked that up and read about that today. And this is variably reliable. It's a real challenge to get it to be right. It's an obvious target for fraud and criminal gangs, which is a challenge. It's mostly, in most countries, it's not mandatory. There's a few where they're just assigned at birth, and that's the end of the story. They're actually less a target of fraud because the system's closed after birth. But there's always enrollment processes and challenges with those. But even if countries have identifiers, national identifiers, institutions usually don't use those internally. They usually end up assigning their own identifiers to records for legacy practice reasons, for policy, like a lot of national identifiers, hospitals or GPs or ambulance services or whatever are not allowed to use the national identifier to identify individuals. I couldn't find quickly what the Nigerian policy was on this. But then sometimes the technology is a problem, both feasibility and cost and reliability. And then also institutions deal with people without national identifiers, tourists, non-citizens, refugees, whatever. And so typically institutions assign their own identifiers to records, even in the presence of other identifiers that they can also track. And the other thing that happens is people have role-linked identifiers, which may be time limited. You as a person become a patient and you get a different identifier to if you are registered as a relative for a different patient, or if you practice as a nurse or a doctor, or you have prescriber authority. Typically in most countries, being a prescriber with the authority to prescribe using government subsidized medications is yet another identifier. In some parts of the world, say, emergency physician is yet another identifier. And in fact, in some parts of Australia, emergency physicians practice anonymously so that they are not traceable outside of the emergency. And so for all these reasons, people are assigned identifiers and they come and they go, and it's a challenge. I want to, first of all, one of the things about identifiers is there's basically four different kind of things that are called identifiers. The first is a record identifier. It's assigned to a record and it identifies the record itself. It might be a piece of paper in a filing cabinet, or it might be a database key, and it's private to that particular data store, and it's never reused outside, and it's usually confined to the internal record store. And sometimes they're called technical identifiers. Then there's a version identifier, which is typically assigned to a version of a set of records derived from a primary database. And they're created, the version identifiers are assigned by the source to a copy that they're sending somewhere so that you can track the particular copy. So you might write an identifier on a photocopy of a piece of paper, or you might create an identifier to mark an extracted set of data that you're putting in a file resource or a version 2 message or a fax, whatever. Then there's an object identifier, which is assigned to a real-world entity by some process. And patient identifiers are typically object identifiers. And then you could look across multiple record systems, and all those record systems share that same identifier to represent and connect to the same real world entity. So whether it's a piece of paper in a paper medical record, or it's a entry on a form filed in a filing cabinet at the reception of a GP, everybody has that same identifier, and that's how they connect those records up in theory. And then there's a business identifier, which is typically assigned to a real-world entity by some other process. And you're reusing that to assist you identifying the patient. And the classic is a driver's number. You might have a patient who's also a doctor, who's also a prescriber, who's also an administrator. And on every one of those records, you might saw their driver's number. So the driver's number identifies the real-world entity, but it's associated with multiple records. And so keeping track of the different things loosely called identifier, they identify something different. Sometimes it's inherently obvious, and sometimes they're confused as well. People might reuse a record identifier in a primary source. For instance, the patient master index for the hospital, often their record identifier is used as the object identifier by everybody else. So different identifiers, different purposes, and it's useful to remember these 4 different purposes. One thing that comes up is the difference between a concept and an identifier. These are technical words in FHIR, but they represent connections to wider concepts actually defined in ISO specifications back in the 1940s. But a concept is a thing that is a code, an identifier that is associated with a set of defined properties. And anything that meets that kind of that property is an example of that concept. So male patients or a drug code, multiple instances of drugs get administered all with the same drug code, and multiple patients are male patients. Whereas an identifier, typically what we call identifiers, they identify a single instance of a thing, and they're made by association by some process, and we remember what they are, and we may know some properties about the patient. We might know their name and their gender, but somebody else could exist with exactly the same set of properties and still be a different person and have a different identifier. So identifiers aren't always distinguished by property. There's a weird thing in the middle where you can define something by a set of properties, but there's only ever one instance of those properties. Countries, states, regions, suburbs, they are very often defined as either a concept or an identifier, because you can do them either way. But people are defined by their identifiers, not by the properties of the person. You could characterize a person all the way through to their DNA and still not have a unique individual. So they are associated with people. So people deal with multiple different institutions, and each institution has an enrollment process to create a record and assign an identifier for those people. And people will have different identifiers at different institutions. The task for interoperability is to manage that. And organizations have different, and policies have different identifiers, but we'll focus on people because it's sort of easier to describe and it's a familiar problem for everybody. Sometimes the institutions share identifiers, and sometimes they do it variably well. And I have a quick story for you later about how it can be done badly. One of the key problems is that identifying people is challenging. And in all the research I've seen across the world, there's approximately a 2% error rate of registering people, where you either wrongly pick an existing record for someone who is not the person identified by the existing record, or you erroneously create a record for someone you already have a record for. And it's hard. Addresses and names change. They get entered wrongly, and you're looking at them going, is it changed? Is it wrong? It's actually really hard. I'm going to assume some people in the room have done this. Clerical staff are rushed and stressed, and they have pressure to do stuff. It's noisy. People have weird spelling names. Man, look at mine. And so it's common for there to be an error rate. And so the constant need to repair records. In HL7, we define 2 different repair processes because we can't agree across the world on how. So that's something you get to agree on. How do you repair records? Do you merge and actually mash the records together and then realize that you did it wrong because about 2% of those are wrong, and then you have to actually unmash them? And how does that even work? And how maybe you just link them together and claim that this patient matches that other patient record are actually the 2 records, but they're the same person. And how do you manage that? These are hard subjects. And in fact, years ago, I was working as a diagnostic services vendor. And I was called by a customer, a diagnostic service, to a hospital where they were dealing with the hospital. And the renal department in the hospital had just contracted a developer to write them a clinical data repository. And so I sat down and we started working through the API between our system and the system that was being written, both of us on behalf of our actual customers. And about halfway through the day, I said, so how do you guys deal with patient merge? And they looked at me and said, what is patient merge? Which is a sure sign they haven't got much healthcare experience, because it doesn't take long before you run smack bang into merge. And I explained it to them, and I said how that the hospital sends, 200 merges a day. That's what this hospital was doing, because I'd checked 200 merges a day to the diagnostic service. And then the diagnostic service does those merges, and you have to keep up, because the records that come will be merged following the hospital merges. And the vendor's looking at me with big eyes going, what the hell is going on in healthcare? And the diagnostic service key contact sitting next to me goes, no, we don't. We don't do the mergers for the hospital that the hospital does, because we think they're wrong. So we only merge when we think they're right. And the hospital IT guys are looking at me, eyes boggling, and they immediately had this huge argument. We had to call the project off because they couldn't agree about merging records. This is hard stuff. There's people who do this for a living, and they couldn't come to agreement. So this is hard. But let's have a look at actual two systems, and we'll keep away from merge and just look at how it works in FHIR. Here you've got on the left Audrey Hepburn Hospital. They had a patient record, and each patient record has a primary key, which is their internal identifier, an MRN, a name, a mobile, and the national identifier. Over on the other side, Bob Hope Hospital, they had a patient record with a primary key and a patient name, but they have a slave table, detail table, where it has a list of patient identifiers, and each patient identifier has its own key, a type of identifier, and a value. And actually, that's much closer to how it works in FHIR. So let's imagine that in our head, and our task is going to be to sit between Audrey Hepburn and Bob Hope hospitals and copy data from one to the other. It doesn't matter whether we're logic in either institution or we're outside both of them. The essence of our task is the same: to identify the same patient in both institutions and share records between the institutions. So our task is to find a patient in both institutions and copy a service request, like a request to do something, from one institution to another. And here's our patient details. I picked these randomly off the web from an example Nigerian person generator website. Ibukun Blessing Emmanuel, male of age 43, from Lagos Island. A phone number, I hope that's not a real phone number, and a NIN, which example NIN off the NIN website. So I'm assuming that's not a real NIN. But anyway, so we got to find that patient. So we can search on Audrey Hospital, which I'm going to do first. We can search for Audrey Hospital Health for FHIR. We're going to search for a patient that has an identifier, which is the NIN identifier. But actually, this could be any identifier that just happens to be this number. So we can say, well, actually, we're going to search for the NIN. That's actually a full URL. I'll come back to that. And so this way, we're going to search for identifier with this NIN. We could get more than one record, or we could get no records. Maybe the patient is registered at the hospital but doesn't have the NIN, or maybe there were two records and none of them have the NIN. We could search by name and male and birth date and probably get 30 or 40 matches and have no idea which of one of us is which, because there's probably 100 matches, hundreds, born in 1980 with the surname of Emmanuel, family name of Emmanuel. We could tighten that up by searching for phone number. And actually, phone number turns out to be, in the Western world at least, by far the most reliable identifier these days. It's actually more reliable than the institution-signed identifiers. Since mobile phones and people can keep their number, they really care about keeping their number. Anyway, what happens when we do this is we search for a patient and we get back a bundle. This is a JSON response. It says we found 5 matches. We searched for, telling you what the server searched for, and we got back a match with a internal key, which we'll have a look at, and we got other matches. And this is the most likely match, 0.95 score on this match. Probably the right person. Looking inside the record, what you see is multiple identifiers. The patient has an ID, which is the technical identifier for the record, which matches the database primary key. It doesn't have to, but it's one-to-one with the database primary key. So it usually is the database primary key. And then we have a list of identifiers. This one's got 2 additional identifiers. It's got the hospital MRN. That's what tells you it's an MR, medical record number, with an identifier that identifies this particular hospital's MRN and the MRN of 12345 within that hospital, which is, you see, separate, and a good practice, separate to the database primary key. And we also have an official identifier, which is the national identifier for Nigeria. That's what NNNGA stands for, with a reference, which would be defined, that references the NIN authoritatively. And actually, that's something Nigeria gets to do. I made this up out of the top of my head for the purposes of the presentation, but one of the duties, usually of someone like the DHIN, is to agree on what this value is actually going to be. Ideally, it will point to some permalink that redirects to a page which says, hey, the Nigerian national identifier, this is this one. And here's their example NIN for that patient. And so you get that record back with the multiple identifiers. And ideally, every system will report every identifier that it knows for the patient. The more identifiers it reports, the more axis of joining you have as a user of that information. And then the rest of the record is the other information: the patient's name, the home phone number, male, born in 1979 on Christmas Day, the home address, managed by the Audrey Hepburn Hospital. Yeah, that's pretty straightforward. And once you get to know the patient resource, you look at that and go, yeah, that's exactly what that is. Then you do the same search on the other end, and you'll, by hook or by crook, by repeated searching, you'll find another patient. See, this patient's got a different identifier here. The idea is good that identifies the patient record, and that has a medical record number. Oh, I forgot to change it. It would be a different number, but it happens to be the same. And this is an identifier system value that identifies Bob Hope Hospital's medical record number. And that's the only identifier we have. We did not get a national identifier. And so the problem with finding a patient, you've searched by human matching, you've searched on both sides. And so you had a human mediating that. And that's kind of hard for interoperability. It's good when you have a human mediating it, but when you're in the back end and you search for a patient, you get multiple matches, what are you going to do? That's no good. You might get 290 matches. Now what? And also search might not be possible for privacy reasons. The search is defined as deterministic, and maybe that's not quite what you want. To go back to here, for instance, what if you wrote down the phone number differently? What if you wrote down without dashes or with spaces instead of dashes? So, and maybe the source system is really smart about her searches for patients, and they usually are. That's what health databases are good at that. So there's actually a match operation where you give a set of details and say, do you have a match or one or more matches for this patient? So that looks like this. I post to a hospital. In this case, I grab the record from Bob Hope Hospital with the ID from Bob Hope and the person details. And I passed it to Audrey Hepburn Hospital and said, hey, do you actually have good matches for this patient? And the system will go off and figure that out for itself and come back with certain matches that it's confident are the same person. You don't need a human to look at this. You just go ahead and say, okay, we know. So that delegates the smarts to the server. So the server can think through, I know my data, I know my business rules, I know what kind of matching I'm going to do. I can tell you with more confidence than you can who's a patient match because I know what my own policies are. Now, having done that, then we're going to move the service request. So we get a service request from Bob Hope Hospital. It's a bench press regime telling a patient, go on, do bench presses. And the reference is to the patient using the local identifier of the patient record on B. So to move this record to Audrey Hope Hospital, you switch this value to this value, which is the value of the patient that you looked up on the Audrey Hepburn Hospital. And so what happens is moving a record from source to destination implies that you're going to have a mapping table for identities, either technical or real-world identifiers from source to destination. You're going to have lots of them. That's the rule. That's the rule for interoperability code. You're going to have to maintain those mapping tables. You're going to have to fix up the references. You have to understand how those identifiers are used. Were they technical identifiers, real world? Are they version? What's the policy around changing them? Are they ever reused? How do merges work? What about moving records between compartments? That means, for instance, some systems, if you create an encounter on the wrong patient, some systems orphan that encounter and create a new encounter. Other systems simply move it. You've got to keep up with that. And are they shared between the institutions, and how well are they shared? My experience is these things are never written down. They're only gleanable from code, and the code doesn't change when the situation changes. And a lot of the operational problems with interoperability, once the work is done, is because the identifier policy changed due to some downstream change to the system, and the identifier handling and the assumptions about the identifier behavior are written into code. So I just want to talk a little bit about that and the theory of that. Anytime you connect two clinical silos and you match their identifiers, you learn about the mismatches between the clinical silos assumptions. Existing, understood, and tolerated problems, which are very often with identifiers or identifier management, become safety problems, because what was managed by within the clinical silo, the clinical system, becomes unmanaged. And so when you hook up two databases, whether they're in the same institution or in different institutions, surprises will emerge, and you must have a process for dealing with that. In the theory, this is what happens. You've got some rate of adverse events, and you realize that, and there's probably things happening because you didn't know what the situation of the patient was in another hospital. And so you say, well, we're going to connect up the records so that we have a full record for the patient. Now, some things that go wrong are not related to not having the full record, so they don't change. The still rate of them is the same. But all the events caused by not knowing what was going on, they fall away because now you know what's going on with the patient across institutions. But now you have new problems created by the mismatches in expectations around identifier handling and other things between the institutions, new events. These are politically painful for the sponsors of the change. My estimation from watching the process is about 100 times more costly. And so that's something, the real lesson is when you do interoperability and you figure out how to connect two databases together and you make your way through the identifier problems, have processes for it to go wrong, expect it to go wrong, because this is what happens. So thanks for listening. You can tell I could go for days on identifiers after 30 years of doing interoperability wrangling. But I don't have the time. So that was just a very quick introduction to the problem and the technical solution. All the challenges are in how to connect the technical institution, the technical solutions that I showed you, or what's happening in the actual exchanges with what's happening in the data identifiers in the human processes in the background. But to build a community, and good luck doing that in Nigeria, and let us know how we can help. You need clear strategy and architecture, great education. These sessions are kind of education, learning and testing opportunities, which Connectathon's great. And in the end, you need to capture the things you learn about your local practice, convert them to specifications, write them down and agree on them. And that's how you build community. So thanks for listening to me. I always finish up by saying that our point is to disrupt healthcare. And we do that by significantly reducing the cost of data exchange and encouraging the development of open community. But what we're really about is building public treasure that we all own, because we're all richer because we all own it, and we have to look after it and behave responsibly and take care of the treasure that we hold, and doing that through open community transparency. So, and I encourage everybody, if you believe in civil society, and I think we have to, then it's built by people building civil resources. So spend some of your time either joining us to build fire for Nigeria, or some other community that builds public treasure, because that's what the civil community is. So thanks for listening. I'm done. I'm going to hang around. I'm not exactly sure where, but I am welcome to hang around. You can ask me questions in the chat, or maybe we'll have a question. I'm not sure what we're doing with the agenda, but I'm happy to hang around and answer questions. So thank you.
Thank you so much, Grahame. Please, let's just appreciate Grahame for that presentation. I think he was able to comprehensively show us the complexity of the identifier challenge. I want to mention that Grahame is the original author of FIRE, even before the community now decided to adopt it. So one, I think we're very privileged to hear from his wealth of experience. I know that we don't have a lot of time, but I did want to see if we have any questions either in the room or online for Grahame before we let him go. He's also on Australia time, so I think the time difference is a factor. Are there any questions for Grahame from his presentation?
There's a couple in the chat, so I'll deal with them. I sent my slides to the organizers for them to send out. And then, are there ways to manage references such that they have referential integrity? Yes. The common servers, we don't require referential integrity in the standard. You can require it for a business rule for your database. And the servers, most of the servers, or any server you write for yourself, you can turn those rules on. Say, we only have, we always have referential integrity. And my advice is for a primary health record, an EHR, you would always enforce referential integrity. But as soon as you start collecting data downstream in a secondary database, you can't, it's too hard. You need to collect all the data you can have and tolerate broken references. So for me, the difference is whether you're the primary data source. If you are the primary data source, yes, you enforce referential integrity, and you can do that with the common FIRE servers or with your own server.
Thank you very much. Are there any other questions on the chat? Awesome. And I think if there are no... One question over there? Okay, one more question in the room.
Okay. All right. Hi, Grahame. My name is George. I work for EHA Clinic. So my question is there any recommended approach to building reports, on FIRE?
What a good question, because I don't have a good answer. Thanks, George. I mean, the community is working up. So there's basically two approaches. One is that it's a standard RESTful stack for the API itself. And so you can use existing reporting tooling for a RESTful stack. That's variably good, and it does exist. It's nowhere near as slick as SQL-based reporting. The second thing you can do is that some, and lots, don't have to, but many do, implement the FIRE API with a SQL server and some kind of SQL in the background, in which case you just use standard SQL report anyway. And then finally, there's a group working on, you can look up this SQL on FIRE, which is a way to define a transform that transforms from the fire resources to an SQL structure so that you can use SQL to SQL reporting tools. In fact, you can use SQL reporting tools directly. You can just take the JSON structures or the XML structures and turn them straight into SQL. But people who use SQL really hate that because they look at their databases produced and they're really, really deep and nested, because almost always they don't want to engage with the full operational complexity of healthcare, which we do. They just want to pull out summary data. And so the key question for me is, what is the most effective way to get summary data? And everybody's got a different view of what summary they're interested in. And that's why at SQL on Fire, they're saying you define the view that simplifies data the way you want it to be simplified, so that then you can write your simple SQL. So the key is around how and where you deal with the simplification problem.
Thank you so much for those questions and answers. Want to appreciate Grahame again for taking the time to join us and share his insights with us. Thank you so much, Grahame.
Pleasure.
I truly appreciate it. All right, we'll move swiftly along